Alrighty, hope you guys enjoyed a little Michael Jackson to start your day off with. Anyway, what we're going to be doing here is going over graphing linear inequalities and absolute value inequalities. You guys have actually already done graphing just linear inequalities back in Algebra 1. So the linear inequalities shouldn't be too bad. I'm just going to go over a few examples here and post them up. Hopefully you can use those to help you out. When you are graphing linear inequalities, graph of a linear equation separates a coordinate plane into two regions. You're going to have a region that is going to be shaded, and you're going to have a region that is not shaded. Your line, this is just called your boundary of the region. Whenever you want to graph an inequality, or the graph of an inequality is your actual shaded region. So any point in your shaded region satisfies your inequality. In other words, when you try to figure out which way you're going to choose to shade, then you need to substitute values in for x and y and get a true statement. Excuse me. Oh, all over the computer. Gross. You should see what I'm looking at. Green. It's not even the marker. Anyway, okay, a few steps to remember how to graph an inequality. First, you need to determine whether the boundary line should be solid or dashed and graph it. So we need to figure out if the line should be solid or dashed and then graph the boundary. You will have a solid line if you have an equal to or a greater than equal to or a less than equal to or a greater than equal to sign. That means anything on the line is actually going to satisfy the inequality also. You're going to have a dashed line if you have less than or greater than equal to. So that's how to tell whether your line is either dashed or solid. Now to determine whether you have a point on your line or not, that is just going to be when you're looking at your boundary. So you're going to choose a point that is not on the boundary. Usually I would suggest maybe the point 0, 0, because that's going to be the easiest one to plug in. As long as it's not on your boundary line, that should be okay. Test in the region. If a true inequality results, then shade the region containing your test point. So if you plug in a 0, 0 and your values work out, then you would shade that region. If your inequality is true. If you get a false inequality, then you need to shade the other region. So let's look at example number 1 here. The best and first thing you should do is solve this equation for y. So we're going to subtract x to both sides. And when you do that, we get a negative 2y is less than negative x plus 4. And so the next thing we need to do is we need to divide everything by negative 2. Now keep in mind we are dividing by a negative, so when we divide by a negative, even though it gives us a positive y on the right, the sign needs to flip. It needs to become a greater than. So then we're going to have a 1/2 x minus 2. So let's go ahead and graph this line just like you would any line that's in slope-intercept form. You're going to go down 2, put your first dot. Then you're going to go to up 1 over 2. Use your slope. Up 1 over 2. It's a positive slope. Down 1, back 2, down 1, back 2, down 1, back 2. And then just draw on your line. Well, should this be dashed or solid? I guess I should have figured that out before I drew all this in. Because of your line here, or because of your sign, that says that our line should actually be dashed. So this should be a dashed line, not solid. So we're going to have to go through and erase a couple things. So let me grab my erase tool here. Ooh, there'll be some big dashes. So here's our dashed line. There's our dashed line. Now we need to figure out if we are going to shade above or below. So this is where you want to test a value. So 0, 0 is not on our line. So we're going to test the point 0, 0. Alright, so when we plug these in, plug it into your original equation or this equation you solved for y, it doesn't matter. So if I plug it in the top, I'm going to say 0 minus 2 times 0 is less than 4. And you simplify. So 0 minus, well, this is 0 minus 0, which is just 0. Is 0 less than 4? Is this a true statement? Well, last time I checked, and I think that was this weekend, 0 is less than 4. So what we're going to do is, that means this point right here would be in the shaded region. So I'm going to just use some lines here. I'm not going to shade it too much. This is just called a little bit of shading here. And then you can draw your lines the other way too if you want. It's called cross-hatching. It's up to you. If you want to make your lines all nice and pretty, that's fine too. But everything up here in this shaded region is going to be part of your graph. So if I maybe just shade all this in here, these are all, everything above the dashed blue line. So whatever x value you choose in this red area, that would work. That would satisfy your inequality. Remember, inequalities mean you can have more than one answer. Make sure we get this all pretty and colored in here. Now anything below this line is not going to work for your inequality. So that's example 1.